Yes. Finally a new video by Decodes.
Welcome back to Decodes, guys. Well, it's been long since I've uploaded my last video and I've not been consistent with my videos too, but this video is on demand and I would like to discuss with you guys how we can use data preprocessing and what types of tools and what types of variations we have in data preprocessing and everything. So today we'll be discussing it in Python, but I am going to provide you with the data set of this code itself, and also I'm going to provide you the template for data preprocessing in Python as well as in our language. So let's get started. So initially we will import the libraries NumPy, Matplotlib, PyPlot and Pandas. So let's get familiarized with our data set. Okay, so here is the data set. So this is a dirty data set. Why it's a dirty data set? We can see that in the age column there is a null, salary column there is a null value. None of these values has a range in it, that is salary can go from 0 to infinity, age can go from 0 to infinity. Well, not till infinity, but yeah, it has some limiting values, but we are not sure. It does not have a certain limit. So all those things should be taken into consideration. What are the other things that can affect your data set are, like in the purchased column you can see there is a no yes, no yes, no yes. But if suddenly there comes a no yes, 1, 2, 3, so that is dirty. So all those things you have to take into consideration. In today's video, we are going to do some feature scaling. I'll explain it on the way what all those are. So let's get into it. So hope you are now familiar with the data set. So we have imported the libraries. We are importing the data set. I said the first three columns, that is the country, age and salary will be in the X and purchase will be in the Y. This is X and this is Y. Okay, so as you can see, the value where there were no values, it got converted into NaN, no values, null values. So we have to take care of that. So there are two options we can do. Either we can fill it with some data or we can just cancel the whole column. So it's up to you what you have to do. Most of the times we drop it if it's a very big data set, or if you necessarily need it, we try to fill it. So we'll see how we do that. So taking care of missing data sets. So we need a simple imputer. You can read about simple imputer. I'll be providing the link to it to the scikit-learn in the description. So I say that missing value is np, that is our numpy array dot nan. What was nan? Nan was the missing values. So in numpy arrays, wherever there is nan, we have to fill it with a strategy called mean, that is taking the mean of the whole column and filling it in the place where there is nan. So if there are multiple nans in the same column, all the nans will be filled with the same values. I hope you guys understood what how we took care of the missing data set here, right? So we said imputer fit 1 to 3 and yes, imputer transform 1 to 3, yes. So it's done. 1, 2, 3 means basically avoiding the first column, that is this country names, France, Spain, Germany and everything. Okay, so that happened. And yeah, we print it and see what happens. Yeah, you see, we took the mean of all the columns of the last what the column was that? It was, I think, salary. Yes, so it took the mean of all the salaries and it filled it in here, that is 63,777. yeah, 0.7 recurring. And similarly the age also 38.7 recurring. So yeah, now what we are going to do is encoding categorical data. Why do we need encoding? So when you are training a model, there are more advanced training models today that are available today that does not need much of encoding. Like you can just give an input as a string value and it will understand it. But since we are brushing up our basics and everything, we need to learn about encoding data. So this string data set, like you see France, Spain, Germany and everything, this is a string data. So we need to encode it. Now there are two types of encoding. That one is one hot encoder and the other one is label encoder. The most commonly used, there are other types of encoding too, but most commonly used two are one hot encoder and label encoder. Okay, so what is the difference between those two encoder? So here, as you can see, I have used one hot encoder. Okay, one hot encoder is used when there is some relation, or there can be some relation between one or two columns, that models that we are going to train in it. Label encoder is used when we are just encoding a label. For example, let us consider there is a column that includes values only girls, boys, transgenders, and then again girls, boys, transgenders, and so on, like only girls, boys and transgenders. Okay, so but it does not affect any of the columns. For example, like if there's a job opportunity and it is not gender biased, it should not be gender biased, right? So you have to take into consideration that that column, that is the gender column, boys, girl, and transgender and whatever it is, it should not affect any other column. So what we do is we just give it a label encoding. Hence it is not affecting any of the other columns. We just assume it's just a label and we use label encoding. So label encoding converts it into any type of numerical encoding. So what one hot encoder does is, it sees France, it sees Spain, Germany and everything, and since all this is in a independent variable, it transforms them into a binary data. So as you can see here, the first one is 1000. So, and again this is the same one. So that means this and this is France, and this is, I think, Spain. So that is how it sees a certain relation and then transform into a binary data set. Okay, so if I have to say that this column transformer is used to transform the whole column itself, as you can see by in the name itself. And okay, the parameters here is encoder, one hot encoder that we have already called from the preprocessing library in scikit-learn. The 0 means the index of the column that we have to transform. We have to transform the 0th column, right? So we gave 0. Remainder is equal to pass through. So we are not going to discuss different types of remainder. There is called a drop and there is a pass through and everything. So you just read on it in the scikit-learn. I will provide the link for it too. Okay. Now we fit transform it. Since it's all the independent variables, we fit transform it, and yeah, here is the result. Now dependent variable. Okay, what was that? We saw this, since the purchased column has only yes and no and yes and no and everything. So it's just a label. It can either be let's say a binary value of 0s and 1, or it can be numerical value of 1 or 2. Whatever it is, it's just a label, right? It does not affect any other column, or it won't change the way your model is getting trained or anything. So we use the label encoder in it. We say that y, that is this purchased column, has to be fit transform for it. So so it used 0 for no and 1 for yes. So it was as simple as that. And now we use the dataset splitting. Splitting dataset should be a very important part. So what I did here is use a train test split. What it does is it splits into 4 parts, that is xtrain, xtest, ytrain and ytest. What we have to take into consideration here is test size. The test size is set 0.2, that is 20% of the whole dataset is for training. Oh, sorry, for testing, and the remaining 80% is took for training. So I have printed the xtrain, this include all these values, and xtest include all these values. And if you take a closer look in it, all these values are in 2D array. You have to remember it while you have to giving inputs and everything. Okay, so that's it. And then comes feature scaling. Okay, so as I said about feature scaling, you know, it's when we see the word scaling itself, we know that values are going to change according to our given scale. So why we use feature scaling? As I said, salary can go from 0 to infinity, right? Or in the worst case scenario, let's say negative. So if the values are going from 0 to infinity, what we have to do is take into consideration that all the values should come under a certain range. Like what is the use of it? Okay, if you are doing a classification problem and you have so many values that goes from 0 to infinity, it becomes tougher and time consuming for the model to get or learn a certain type of pattern between all these values. So what we should do is feature scale it into a certain range. Let's say 0 to 2 or -2 to 2. So inside -2 to 2, there are infinite number of values with a decimal point, right? It's not like the values are contained. So each and every value till infinity can be featured into this small range, and everything can be then took into consideration for a certain kind of pattern. Since age is also does not have any restriction, we are feature scaling that too. So how this actually works is, use the standard scaler in the preprocessing library. We called it as SE, and we fit transform X train, and we only transform X test. So I hope you are familiar with the process of fitting and why not fitting X test. Whenever we are training a model, that is only training part of the data set should be fit. Rest all should be transformed, only transformed. It should not be fit, because it should not find a pattern itself, otherwise it will overfit. So that is why. So if I print the X train, yeah, so this is what it is. So the values that were in thousands now lie between let's say, I think -2 to 2 itself, right? Yeah, so it came, everything came into a range. So now if you look into this data set, none of the values is numerical, none of the values is out of bounds or out of range, everything is inside. Now it is easier for a model to train. So what all things did we discuss today? We discussed about importing libraries, importing dataset, splitting the libraries into X and Y. The most common practice, the most common practice is the last column is Y and the rest all is X, but it depends on. And taking care of the missing dataset. As I said, there are two most commonly used ways of taking care of the missing dataset. One is taking the mean of whole values and filling it with it, or just neglect the whole row itself. So yeah, so hope you understood that. Encoding the data set, that two types of encoding there was: label encoding that we discussed, label encoding, and one-hot encoding. One-hot encoder when there is some kind of relation or we need to train it. Label encoding if it's a label like girl or boy or yes or no. Let's say for weather condition, cloudy, misty, all those are labels. Then comes encoding the dependent variable. Dependent variable was the label encoder part, and splitting the training and test data set. And then there was feature scaling, getting the whole range of infinite values into a small range of infinite values. So I hope you guys understood what are different tools used in data preprocessing. I'll again say that I'll be sharing this data set, the code in Python as well as in R will be shared to you guys in the description. Thank you so much. I hope you understood all these tools and everything. See you in the next lecture.